Good day, ladies and gents. My name is LTS, and today I'm just revising maths for an upcoming test. So we're doing calculus. Better yet, I'm doing calculus. Okay, so let's go. So basically, we'll be deriving logarithms today. So let's say if we're given log x plus a, right? Let's say we're given this, right? So and then this is equals to y, and then we're told to find y prime, or dy over dx, right? So we have our y is equals to log a x, d over dx. Right, I'm gonna do it step by step, just so whoever's learning this afresh could learn it afresh. And so I also know the rules. So this is equals to dy over dx, which is equals to which is equals to 1 over x, and then the base of log, which is a. And so how did we come about this? Now I'm assuming that you know that if I've got a to the exponent of x is equals to, let's say, y, and if I derive a to the exponent of x, so dy over dx, I'm gonna get a to the exponent of x, then a. I'm assuming you know that. So if this is the case, then if you were to make the following, if you were to say, okay, sure, you know that log x base a, we're given this, but we know that it can be rewritten as a to exponent of y is equals to x. Right? Then we derive ay, so we derive on both sides x. So what we will get here is a y. Now you multiply, right? Multiplied by what? Well, multiplied by the name. That's the base, right? And then it's equals, right, times the derivative of the exponent, which is dy over dx, which is equals to 1. And so we have ay times then a ay, and a not over, and we divide both sides by ay, then a. And so we have dy over dx is equals to 1 over ay, then a. But we know that our y is equals to log ax, right? So dy over dx is equals to 1 over a log ax, then a. Right. So if that is the case, if you have e and then you have to the exponent of then x, the answer would be x, right? So the same is here, right? So it's like this, and then the inverse of this, and then just if you just wanna grasp it quickly, you would just say they cancel out, but mathematically speaking, they don't. There's actually a way of proving this. I'm not going to go into detail, and I'm not going to go into for today. So dy over dx. I might. I don't know. I'm not going to go after this revision. So we have x, then a. So these are equal. You see. Okay, so I'm gonna give you a couple of questions to please try to do. And I'm doing them on my own also. Yeah, compare answers. So these are like examples. Example 1 says, given y is equals to log x, find y prime or dy over dx. So I have that y is equals to log x, and so d over dx y should be equals to d over dx log x, and so dy over dx should equals to 1 over that, and then ln base, which is 10. And you could, then we have number 2, we should say, given the following, y is equals to log 10 log 2 plus cos x base 10 find y prime. So again here, I'm not going to rewrite this, it's kind of too long, so I'm gonna just say d over dx y is equals to d over dx log 2 plus cos x is 10. So dy over dx is thus equals to 1 over 2 plus cos x times ln 10. There's something very important that we need to note in this case, which is that here we have a composite function, right? So you need to know that when deriving composite functions, we tend to use the chain rule. So how I remember the chain rule saying so I remember the chain rule. Let's see, we did it for F5. So how I remember the chain rule is you first have to touch her outside. Don't judge me, please. But you first have to touch the woman outside. So you touch her outside. Times and touch her inside. Anyone could use anything to remember it. Women can also make a reference of males. This is just how I remember it. Because, I kinda had a sexual teacher when I was in grade 12, and that's hardly the reason why I love maths. So now we need to find the derivative that's touching her outside of the inside function, which is what? 2 plus cos x. That's v equals to 1 over 2 plus cos x, then 10 times this one. Derivative of 2 with respect to x is 0. As derivative of cos with respect to x is negative sine x. We also perform the chain rule here, but it's unnecessary since it's going to give us times 1. Right? And we have, so now we have negative sine x 1 over 2 plus cos x, then 10. So that's our example number 2. And for example number 3, he gave us, given that we have this plus 1, we need to find this. So this equals to this. So we need to find this. So we have 1 over x cubed plus 1. Now I need you guys to notice something, so I'm gonna write it on full. Alright, so and myself to notice something. So we're going to have then this is like log e. It's log x cubed plus 1 to the base e. So the base is e. And then multiplied by the derivative of what's inside, which is x cubed plus 1. So what we get here is 3x squared over x cubed plus 1. This is times 1. This part is times 1. So why is that? Now let's figure it out. So if we have then e, let's let it equals to y. Right, so we have log e equals to y. Right, so e to the exponent of y is equals to e. So that means that y is equals to 1. See? And y is equals to that, so e is equals to that. Let's do question 4. So question 4 says given that x, given this, let us find this. And so d over dx y d over dx so we have dy over dx 1 over sine x, right, times lim e, we chose 1, so we could leave it. And now we need to differentiate what is inside. So what's inside is cos x, right? So we get is dy over dx equals to sorry for that. So what is inside is sin x. This derived without deriving, that was amazing. I'm joking. So you have cos x over sin x, which dy over dx should be equals to cot x. And then question 5 says given that y is equals to then x exponent of 1 over 2. Let's find that. Find y prime. So y prime, remember, is equals to dy over dx. So don't be confused when I dy over dx. So I just prefer the notation. So d over dx is equals to d over dx so this is what we have. So dy over dx should be equals to, again, I want to repeat it because I think some people do get offended by this. So I'm gonna just do it. So I'm gonna derive the outside function first. And then derive the inside function. I'm gonna just make it a long process. So we're gonna have like we're still going to, I'm gonna do this, let me do this. Then x exponent of negative 1, right? And multiplied by derivative of this is 1 over x, right? So what I'm going to get is 1 over 2x root then x. So this is our solution. Okay, problem 6. So y is equals to then x plus 1 over root x minus 2 we need to derive that sign. So find y prime, which is equals to dy by dx, just for emphasis sake. So d over dx y is equal to d over dx. I hate when it does this. Is equal to d over dx. Then x plus 1 over x minus 2. Timber. Wouldn't me. I wouldn't dream of challenging me. So we get 1 over x plus 1 over root x minus 2. So this is what we get. Right, so times the derivative of the inside. Yes, because we good mathematicians. But the inside is demanding too much. Do you guys see? It's like, hey, I want you to think. I don't want to think. I'm a lazy individual. I'm a good mathematician. I'm joking. Nah, I don't think. Please behave. Where the line's going? So remember here, I'm just going to swap. So we're going to get plus 2. The line is all of a sudden up there. Wow. But I think you saw that part when x plus 1. I think you saw that part before the line got there. By the way, this is a Lenovo Tab M11. You could buy an iPhone and do the same thing, but I don't think you misbehave like this is. Times. So first here you differentiate the top, so the top is 1, and you keep the bottom, and you subtract, then you keep the top, differentiate the bottom, times 1, and you square the bottom. So you get this. Forgive me for bumping. See, if they just said find y prime, you could just leave it here on the top, or you could just leave it here. Okay, I'm gonna leave it after this thing. I don't think I want this struggle. I'm a lazy individual. I'm not that lazy though. Last but not least, we've got 7 f of x is equals to log x squared plus x. one person that says, yeah, this one is really nice, honestly speaking. It's different. And different is always nice. So, I'm going to like 1 over x squared plus, just keep everything the same, as pi 6 e plus sine x. So this is like our first part, and then 6 is our first part. Then we're going to derive the inside, and I hope you have the notations down. And so deriving the inside will give us what? 2x, right? Plus the one that never changes, plus 0 plus cos x. So you will get 2x plus 1 never changes plus cos x over, just said find f prime of x, so we're not going to simplify any further. X squared plus e to the x plus pi to the e. Why is this one 0? Because it's not in terms of x, you see, and e, pi and e are constants, so they make a constant. And sine x, then x, then 6. Relax. What? What are you doing? So, yeah, this is what we have. So, thank you guys for chilling with me. For us talking that together. So, yeah. Wait. Let's just prove a meeting in logarithmic functions. So we have, this is just the bonus question, dx, then absolute value of x. This equals to 1 over x over absolute value of x times x over absolute value of x over x squared equals square over x. Just know that the derivative of ln absolute value of x is equals to 1 over x. Okay, thank you for watching. Bye.